In this video, I will explain to you how to write a function that can tell you whether a year is a leap year or not. Before we do any coding on this function, let's first define our problems and draw the logic flow. So what do we know of a leap year? First of all, a leap year can be divided by 4. However, when the year is a new century, so divisible by 100, the year is not a leap year. There's one exception on this rule, and this is when the year is divisible by 400. As you may notice, we need to prioritize some rules over. Take for example the year 2100. 2100 is divisible by 4, so according to this rule it qualifies as a leap year. However, 2100 is also divisible by 100. Therefore it's a new century and it does not qualify as a leap year. So we should first check whether it's a new century before dividing by 4. Another example is the year 2400, which is divisible by 100, so a new century, so not a leap year. However, this is one of the exceptions where the new century can also be divided by 400. Therefore, this year does qualify as a leap year. These examples show that the order of your code is extremely important. You should first check whether you can divide by 400, then by 100, and then by 4. Now we know this, let's draw the logic flow of our code. First of all, let's check if the year can be divided by 400. If this is the case, it's always a leap year. If it's not true, we can move to the second rule. We have eliminated all years divisible by 400, so now we can check whether the year can be divided by 100. If this is the case, it's not a leap year. If this is also not true, we can check if we can divide the year by 4. If this is true, the year is indeed a leap year. If this is not the case, then we're talking about all other remaining years that are not leap years. Now, let's open a new file in MATLAB. We want a function with a year as an input. Since we use the display function of MATLAB for the output, the code will always generate an output, so we don't need to define one here. Furthermore, we will use conditional statements to check whether the year is a leap year. So let's already write the if and close this with an end. Now, how do we ask MATLAB whether a number is divisible by 4? We will need to find a suitable function that can divide a number by 4 and tell us if that gives a round number or not. The exercise already gives a hint on where to look. Under Home, you can find the help function of MATLAB. Click it and then go to MATLAB because that's what we're using. Language fundamentals, here you can find all the operators. Then operators and elementary operations, and since we're doing division, let's check arithmetic. We are looking for something that can tell us that when we divide a number, whether it's a round number or not. So let's see if we can find something that suits that. Remainder after division. That sounds like it could tell us if we get a round number or not. It's called the mod function. Let's click it. Here we find that the mod function returns the remainder after division of a by m. This sentence is still a little vague, so let me explain to you what this modulus function of MATLAB does in a bit more detail. The modulus function returns the remainder after division. So this means that when you divide two numbers, say you divide a by m, m fits a certain amount of times into a, an integer amount of times. And when they don't exactly fit, you will have a remainder number. And this remainder, b, is what the modulus function returns. That still sounds quite complicated, so let's give an example. I'm pretty sure you also had to do these sums in primary school. When you, for example, divide 18 by 4, 4 fits exactly 4 times into 18. However, you will have a remaining number of 2. Now, this is exactly the same as what the modulus function does. 18 is here a, 4 is m, and b is the outcome of the modulus function, which is 2. This means that when two numbers are divisible by each other, b will be 0. And there we have the first if statement of our code. Now let's check back with our logic flow what we first had to put in our if statement. That was whether the year could be divided by 400. Then we'll ask whether the year can be divided by 100, and then we'll ask whether the year can be divided by 4. So let's put this into MATLAB. So we say if the modulus of the year divided by 400 equals 0, please watch the double equal sign here, because remember, a single equal sign means you define a variable, and a double equal sign means you ask MATLAB whether the two are equal. So one equal sign is a definition, and two equal signs is a question. So let's get back to MATLABing. We already have our first if statement, which is if the year can be divided by 400. And if this is true, we display this year as the leap year. Mind the apostrophes in the display because we are displaying a string. Second if statement is if the year can be divided by 100. If this is the case, we display that the year is not a leap year. Then the third if statement, if the year can be divided by 4. If this is true, the year is a leap year. And then we have all the remaining years that are not leap years and also do not meet all the other requirements. And these years are not leap years. Now let's test whether this works. First save it and now execute. Let's try some of the example years given in the handout. For example, you can use 2002. It's not a leap year, and that's correct. Then 2004 is indeed a leap year. 2010 is not a leap year. 2100 is not a leap year. It seems like our function is working perfectly, so we now have successfully written a function that can determine whether a year is a leap year or not.